In this episode, we discuss the issue of how to represent data and to optimally learn from it. Many of us are familiar with conventional machine learning methods, things like support vector machines or decision trees, linear regression even would qualify. But there are other ways that you can represent data that may make the challenge more learnable. And one of the newer methods is called topological data analysis. The main concept with topological data analysis is that you look for shape in the data as opposed to viewing it simply as a number. And that is the crux of the debate today is, do you get a significant advantage by using topological data analysis compared to conventional machine learning? The two discussants today are Yashbir Singh, who will discuss topological data analysis, and Ali Ganjizadeh, who will discuss how to use conventional machine learning.
Topological data analysis is a mathematical approach that uses topology, geometry, and algebra to analyze complex and noisy data. It outperforms conventional machine learning model in medical science and imaging for three main reasons. Firstly, topological data analysis can handle heterogeneous and multimodal data more effectively than conventional machine learning model. Topological data analysis can integrate different data types into a unified representation that preserves their intrinsic properties and relationship, which is common in medical science and imaging. Secondly, topological data analysis can provide more interpretable and explainable results than conventional machine learning model. Topological data analysis generates visualization or summarizes that reveal the underlying structure or shape of the data, such as persistent diagram, barcode, map graph, making it easier to understand and verify the validity or reliability of predictions or decision. Thirdly, topological data analysis can be more robust and generalizable than conventional machine learning model. Topological data analysis captures invariant features or pattern in a data that do not change under transformation, such as scaling, rotation, or noise, which ensure that predictions or decisions are consistent and accurate across different settings or scenario. In conclusion, topological data analysis is an effective tool for analyzing medical data due to its ability to handle heterogeneous and multimodal data, provide interpretable and explainable results, and be more robust and generalizable. Its application can lead to better informed decisions, ultimately resulting in improved health outcomes for patients.
Conventional machine learning is a branch of artificial intelligence that uses algorithms and statistical models to learn from data and make predictions or decisions. It can be divided into two main types: supervised and unsupervised. Supervised learning uses labeled data to train a model to predict labels for new data. Unsupervised learning finds patterns and structures in unlabeled data. These are the main reasons I think conventional machine learning is more useful than topological data analysis for this field. First, conventional machine learning models are more established and validated than TDA methods. There are many frameworks and libraries that support conventional machine learning, such as TensorFlow, PyTorch, and scikit-learn. There are also many benchmarks and datasets that evaluate conventional machine learning models on various tasks, such as image classification, segmentation, and detection. TDA methods are still relatively novel and experimental and may lack sufficient evidence or validation. I would disagree that TDA methods are more explainable This depends heavily on specific machine learning methods you use. Decision trees are far more understandable than a persistent diagram. Support vector machines perhaps are more challenging to understand. Still, I think some exact comparison examples are needed to prove this point, as I am not sure what persistent means in terms of adjacent pixel values. Conventional machine learning models can also benefit from transfer learning, which allows them to use pre trained models from other domains or tasks to achieve good performance when data are limited. For example, a model trained on natural images can be fine tuned on chest x rays for pneumonia detection. This means time and resource can be saved while achieving better results than training from scratch. TDA methods may not leverage transfer learning as easily or effectively as conventional machine learning methods. In summary, I think conventional machine learning outperforms topological data analysis for medical sciences and medical image analysis because it is more established and validated, can be more explainable than TDA, and can benefit from transfer learning.
Okay, that was an interesting discussion or comparison of TDA methods and conventional machine learning. So those are the methods. Are there specific types of problems that are better suited to either TDA or conventional machine learning?
So I think topological data analysis may be more suitable for the data with inherent geometry or topological structure, complex problem with the high dimensionality or small data samples and visualization data features. At the same time, conventional machine learning method may be more appropriate for the structured data, large data set, or the problem with the clear objectives. However, the choice between TDA and conventional machine learning ultimately depends on the specific characteristics of the data and the problem you are trying to solve. It is often beneficial to explore and compare the performance of both approaches to determine which one works best for your specific use case.
Yeah, I agree with Yash, but in my opinion, when it comes to predicting the outcomes of medical interventions, CML can be more useful. For example, CML could be used to identify the key factors that contributes to the patient's response to a particular treatment or predicting the adverse effects. So this information can be used to make more informed treatment decisions and improve patients' outcomes and health.
Very good. Explainability is a really popular topic, and we recognize the importance of being able to understand how a machine learning model came to its conclusion. Do you have thoughts about how either CML or TDA is better or worse for explainability, and maybe think about how you would measure explainability within that context?
Well, in my opinion, measuring explainability can be challenging, but some potential approaches in the context of comparing topological data analysis and conventional machine learning could include evaluating the interpretability of TDA visualization, quantifying the level of human comprehension of TDA derived insight, and comparing the transparency and the interpretability of TDA models against the traditional machine learning model using established explainability metrics. Additionally, user feedback and domain expert evaluations could be more incorporated to assess the effectiveness of the explanations provided by TDA and ML models in the real world applications.
Yeah. Uh, I think that sensitivity analysis can be one of the examples that we use. For example, we can use to evaluate the impact of the input features on the model's output by manipulating different inputs and assessing the effect on the model's output, we can determine how well the model's prediction is aligned to our expectations. Another way uh, uh, Another way is to consider the model's architecture itself. By comparing the architectures of the TDA and CML models, we can get an idea about their relative explainability.
Excellent. Well, I want to say thank you to you both, Yash, and to Ali for discussing the issues of conventional machine learning versus topological data analysis and figuring out where these techniques have their strengths and weaknesses. I hope that this discussion has been helpful to you as well.